Alright, gang, here we go. This is for Physics, Unit 8, Part 2, Flat Mirrors. Alright, so first, last unit, remember we talked about this guy, or this last part, we talked about this guy named Huygen. Huygen, and how he established the idea that we can treat all light as rays. Okay, remember, light is made out of waves. They move up and down, and then we have those things, wave fronts, that connect all of our crests. And then if we draw lines tangent to those wave fronts, we get those rays. And essentially, what we're going to do from now on is we're just going to run with that principle. We're just going to assume that it's correct, and we're just going to so from now on, essentially, we're just going to treat light as a ray, especially when we deal with reflection, refraction, and diffraction, and so on and so forth. Okay, so today we're going to talk about reflection. Specifically, we'll talk about reflection in flat mirrors, which is a kind of a simple case, and then the next part we'll move on to curved mirrors, and then lenses, and so on and so forth. So life should get really exciting here pretty quick. Okay, so first of all, reflection occurs whenever your light enters a different medium. So all light travels at the same speed, no matter what, right? 3 times 10 to the 8th meters per second is what is, about what the value is. And so light is always traveling at that speed, and it moves in a constant direction, always in the same straightforward direction until it encounters some medium where it changes. Okay, so when your light hits a mirror, for example, it's going to bounce off your mirror. If your light hits, the table you're sitting at, or your face, or whatever you're looking at, your light is going to bounce, change direction, so on and so forth. And this bouncing is called a reflection. Okay, and so we're going to broadly say there's 2 main types. All right, diffuse reflection is when your light hits a rough surface. Okay, so imagine you have a laser pointer, and we've all played with laser pointers. You point it at the wall, and you see the dot appear on the wall. Now, you see that dot appear because it's being diffused. All right, it's got diffuse reflection going on. Literally, parts of that laser are bouncing off of the wall and hitting your face and hitting your eyes specifically, and then you can see the dot. Without it, the diffusion, without it bouncing off of that spot, you would not be able to see it. Right? So that light, like as that light beam is traveling through the air, but you can't see the beam itself. You can only see where it ends up along the wall on the opposite side. You could imagine that if you took some chalk and spritzed it, like took some erasers and thumped them together and made chalk appear, or like a chalk cloud, you could see the laser. Now you could see the laser because it's being diffused as it hits those individual little chalk pieces in the air that, that are particulated, right? So that's essentially what's happening. So you could also imagine, like, if you had that same laser, but instead of shining it at the wall, you shine it at a mirror. It hits the mirror and is going to bounce off depending on the angle it hits the mirror, right? And so wherever it bounces off, all right, you can see where it lands, but you wouldn't see where it hit the mirror. And that's because the mirror will have it be what's called a specular reflection. Okay, a specular reflection occurs when the light hits a smooth surface. Okay, so this is called a specular reflection. And so we're just going to assume from now on that anytime we talk about reflection, we're specifically talking about specular reflections. All right, so A here, this is diffuse reflection. So notice that it's kind of this rough surface. Your light bounces off and it gets scattered all different ways depending on the angle at which it hits this point, right? And then the specular reflection, this is completely smooth, and so you get all your light rays are bouncing off in the same direction, all right? So what angle do they bounce off? Well, we have to define a couple of things, a couple of new terminology. I'm going to move my face here over to the other side. Okay, and so your angles of incidence and reflection. Your angle of incidence, this is your theta in this picture, all right? That's your theta, and it's the angle between the ray that comes in, all right, and the normal. All right, so the normal, remember when we talked about normal forces way back last semester, we talked about how we had gravity is always pulling down, and then we had the normal force that was always perpendicular to whatever your plane was. Remember, and so we said that if we had a plane that was angled, that our normal force would be perpendicular to that, so it would be up like that at an angle to that guy, or not exactly 90 degrees to whatever your surface is. All right, so same idea here. You've got this normal that goes up and down, so your incoming light hits this. You got your incident angle, and then your angle of reflection. Well, that's going to be the angle, or that's going to be your line, or that's going to be your angle between the normal and wherever your reflection point happens. Okay, so the reflection. The nice thing is that in any reflection, all right, your angle of incidence is always going to be equal to your angle of reflection. All right, so if we can measure this angle of incidence, your angle of reflection, okay, on this side here, and we define that as theta, or prime, okay, is going to be equal to those guys. So your reflected angle would be something like that. All right. Now, I'm not quite sure why we've decided this, but physicists a long time ago decided that these angles would always be measured off this normal instead of off of the surface. All right, and so this angle here, okay, so these two angles will always be equal to each other. So your angle of incidence, angle of reflection, okay, this is important moving on to ray diagrams right here. So ray diagrams is what we're looking at here, okay? And essentially what it is a way of picturing the rays that strike your mirror, okay, and create images. So here we've got a mirror, we've got an object of a pencil, whoops, and this pencil here has an image that gets formed because of the rays that are striking it. Okay, so notice that we have an eye right here, okay, and so we've got these two different rays we're looking at. This first ray bounces off and goes straight and is parallel to the bottom, hits the mirror, and then comes straight back at the eye, okay? And so this guy here, that's kind of what that first ray does. And the second ray comes down here, hits some point. It doesn't really matter where it hits. The only important thing is that it bounces off at the same angle that it hit, right? And we just established, so this would be your angle of incidence, and this would be your angle of reflection. So those two need to be equal to one another. So this angle comes down, hits the wall, and bounces off this way, right? And these two angles should be equal to one another. Now the trick here, and the reason this is important, is because our eyes and our brains don't quite understand the way that we interpret this information. Our brains don't understand that how this object came to be, right? Or these two line images, because your brain sees and looks and sees these two lines that are coming here, and your brain is like, wait a second, there's two rays of lights that I'm intersecting, or that I'm witnessing, that are coming out, right? And so we've got this ray here that's kind of like connected this like that, and then we've got this other ray that goes like this. Okay, and your brain sees these two converging lines and assumes that they have to have had come from the same point. All right, and so your brain sees all this information, the colors and the distance and so on and so forth, and so your brain constructs this image. All right, and it's all because of these fake rays, right? These rays don't really exist. These guys do, or these solid lines, but these dashed lines don't really exist. And your brain kind of just puts together this picture and creates this image based off the rays that it's seeing. And it's all because of the way it's bouncing off of this mirror. Okay, now, so when you're making a ray diagram, okay, we can use a couple of important steps. Step one, these two rays here, in order to create and identify where your image is going to be located, what its height is, okay? And then we're going to also talk about creating ray diagrams, okay? But essentially what you need to know from this picture is that your brain uses these two different rays in order to create this image, all right? Now on this guy here, there's a couple of new terms. Notice this is the exact same picture, okay? But there's some new terms that you need to know. All right, P is the image distance, or the object distance. Okay, this is your object distance, your distance from your object to your mirror, and your Q is your image distance, or the distance of the image to the mirror. All right. Notice that in a flat mirror, these two are always equal to each other, and that makes sense. As far away as it is here, that's how far away this guy should be. Okay, And then the other one you need to know is this h, and h stands for height. All right. So this is the height of the object, and the height of the object will always be equal to the height of the image, and that's h prime. All right. So these two heights should always be equal to each other, and that also makes sense. If you're standing in front of a flat mirror, it's going to show you exactly how tall you are, right? But if you stand in front of a curvy mirror, right, like at a circus, a fun house or something, it's going to show you a different height. It'll show you extra tall or extra short and fat, tall and skinny, etc. Okay, we define this object, and there's several different types of objects we can have, specifically, or images, okay, and we say this image for a flat mirror is virtual. Okay, this image is virtual, and we specifically say it's a virtual image because these light rays don't really exist. Our brain has taken these fake light rays to construct this image, so this image doesn't really exist. All right. So now we're going to change pace. We're going to try something new. We're going to jump over to Paint here, and we're going to start. We're going to do a couple of different things here. All right. First thing we're going to do, here I've got my object, and I've just drawn an arrow. This is pretty standard for what we do for physics to create our guys. And what we're going to do is we're going to determine where our image would be located on the other side of this guy here. Okay. So the first ray we do, remember our first ray is going to be horizontal to our surface. All right. So we're going to take our guy, and I hope this works. Doesn't work. Oh, we got to do this here. All right, so we're going to take this guy and we're going to go. Nope. All right, let's try this. So we're going to take this. There we go. And we're going to go horizontal to our surface. Okay. Like so. And then on the other side of our surface, we're going to keep going straight. So we're just going to draw this guy completely straight across like so. But on the other side, we have to make it dashed because this ray doesn't really exist. Okay, so there's our dashed ray. All right, now we've got, and so this guy comes in, it's going to bounce off this way. Oh, that's really not that pretty, but that's all right. So it goes like that, and then it bounces back off towards the guy's face, or towards the object like this. All right, so there's that ray. All right, that one's easy, right? It's just straight across, make it dashed. The second ray can really go anywhere. It just needs to strike this wall, and it needs to strike it at the same angle. Okay, so we'll take this guy here, and we'll go down here like so. Okay, so there's that one there. All right, and then we're going to draw it. Now this is the tricky part, is how am I going to do this on Paint? So we need like a normal ray or a normal line to this guy here. So there's our normal. All right, and then we're going to draw this angle here has to be equal to this angle here. All right, so there's this guy, and we're gonna eyeball it. Maybe so on and so forth, something like that. Oops. So there's that. Oh, come on. And that one there. So there's our ray for that guy there. All right. Now on the other side, this ray here is going to, remember, it bounces up this way off this angle here. Okay. And it diverges from this point. So it's going to go somewhere like that. And again, because it is on this side, it is a dashed line. All right. Now this point here where these two guys intersect, that is going to be the same point as what we had over here. So this here will be the point of our object. All right. So that's the point of our arrow. Okay. So we'll take all that guy here, and then now what we're going to do is we're going to do the same thing for the bottom part. All right. So maybe, hopefully you're doing this with me. Okay. Delete. There we go. And we're going to do it with this bottom part of our arrow, and then we can use the top and the bottom to create the image and figure out where the image is supposed to be. So we're going to do the same thing with the bottom. All right, so the first one is, oops, we don't want that at all. We want a line. So we're going to go from here to here, okay? And it goes straight across like so, right? And it comes out here like that and then bounces off. Go in the opposite direction, right? And then on this side here it would be dashed, but be a little lazy. All right, now the second one here is going to come up here like so, and it's going to hit some point, right? And then from here it's going to bounce off, but we need our normal again, so we get it just right. All right, or as close to right as we possibly can on paint. All right, and then so this guy is going to come out, oh, something like that. Cool? Maybe that's a little steep, but whatever. And then this guy is going to come out, and it's going to be like, we want to make that parallel. All right, something like that maybe. Okay, so then where those two meet, that's going to be the bottom part of our arrow, right? So it'd be like this. And then from there, we can take that and we can draw in our arrow, right? It would be something like this. And if we wanted to be super exact, we could just color it all in. And then we can erase all of our lines. And really, we should end up all of our rays here, and we should end up with the same exact image, right? And it should be the same distance away from the mirror here. It's not quite, and that's mostly because I'm doing it in paint. It's hard to measure those angles directly. Okay, so it should be the exact same distance away, and it should be the same height as well. All right, so that's pretty fun. Okay, now let's try it again. Okay, or let's try something a little different. All right, so this way we're going to show how to draw like an actual ray diagram, all right, that utilizes our as if we had some sort of eye that was watching our object. So we're going to draw our eye. It's up here. All right, it comes down here like this, and then why is it doing this to me? And so there's our creepy eye right here. All right, there's our eye. I just need to write harder. Okay. So anyway, so here's our eye. Let's watch this guy. All right. Now what we're going to do whenever we do this is we're going to take a couple of cheats. Okay. The first cheat we're going to do is because we have a flat mirror, is we're going to assume that, and it's not really like an assumption, it's just a rule of flat mirrors, that the object and its image are going to be the same distance away from the mirror, right? So what we're going to do here, all right, is we're going to measure the distance from the base to the mirror, okay? And so what I want to do is we're going to do a little paint magic here. So I'm going to take this guy here, and I'm going to draw like myself a little line going from here, okay, to my mirror, okay? Yeah, like so. And then what I'm going to do is I'm going to grab it and I'm just going to duplicate it, right? Yeah, you guys are like, oh my goodness, this guy's pretty clever, right? All right, so there's this end of it right there, okay? And then we're going to make it the same height as well. So what we're going to do is we're going to take this guy. Oop, we want a line tool. We're going to start here, and we got to make it the same height, so it's going to go from here to here, okay? And then we're going to grab it, and we're just going to move it over here, so there's your same height, okay? And then we also need to know this distance as well. All right, so we're going to go from this point to that point, okay? And we'll grab it. All right, and this would be a lot easier on paper, something not in paint for sure. All right, and then there's that guy. So really, then to make my image, so instead of doing all of those guys we just did before with all those rays, those two rays to show everybody or show everything, really we could just do it like this, okay, and we can just make some measurements, so on, so forth. So there's our image, and now we can get rid of all of our pink lines. All right, so pink, go away, pink, go away, pink, go away, and pink, go away. All right, so now we've got our object and its image. Okay, so what we want to know is what rays does our eye actually see? All right, so the rays that our eye actually sees, there's an easy way to do this. All you have to do for this is you're going to pick a point on your object or on your image, and you're going to draw a straight line to your eye. Okay, and so it goes like this, like that. But remember, this side of it is a virtual, it's not real. So this side has to be a dashed line. So we're going to turn this into a dashed line. Okay. All right, so there's that guy. And then this object, this ray here, had to have come from this point here. So we're going to take this line here. We're just going to draw a straight line to this point. All right, so that's where that ray came from. So this ray bounced off here, and notice that because we did it this way and we found our object, that this angle of incidence and angle of reflection automatically matched each other. We didn't even have to think about it. Okay, all we had to do was draw it from here straight to our eye, and then draw it from whatever point it would have come from the real object. And then we can do the same thing from another point here. We'll do it from down here. Why not? Okay, so there's that guy. All right, and so this guy went like that, like this, and we need the arrows to show the direction of the ray, and then this guy would have come from here, right, because it would have come from down there, and again, we need this guy like that. All right, and then we make it dashed. All right. And so that's how you draw a ray diagram. And you could do, and really essentially what's going on is your eye sees millions and billions of these rays all at once whenever it sees any object. And so your brain takes all those rays and turns it into information, and it turns it into an image that you can understand. All right, so really we just need two to figure out the object and the ray diagrams, but you could do infinitely many, or like if you had a really complex shape, you could do one from each corner, like so say you were doing a Christmas tree or something, you could do one from each branch, so on and so forth. So anyway, so practice making some ray diagrams. Okay, so it can be kind of tricky to figure out how to do it on your own. All right, but just kind of, do those steps one at a time. Let me know if you have any questions, and I'll see you on the flip side.